Hello students, in the last lecture we have already studied about the electric potential due to electric dynamics. Now our next topic is equipotential surfaces. First of all, our question is what is equipotential surface? Then a surface at every point of which the potential due to charge distribution is the same is called equipotential surface. It means if you are plotting a surface of uniform electric field, just as suppose, then these surfaces are equipotential surfaces. Plane surfaces are equipotential surfaces. When you plot a equipotential surface for isolated charge, then these concentric surfaces are equipotential surface. It is of plus charge. Now, what are the properties of equipotential surfaces? First property is there is no any work done when we move a test charge from one point to another on an equipotential surface. Okay, why it is 0? Now, you see here, suppose it is equipotential surface, okay? And you are taking 2 points on the equipotential surface. First is A and second is B. And suppose their potentials are VA and VB, and you are moving a test charge from VA to VB. Okay? Then what will be the work done? From the formula, work done will be what? Work done will be equals to VAB into Q naught. And what is VAB? That is the potential difference between points B and A into Q naught. And since it is equipotential surface, so VA equals to VB and the work done will be 0. Now, next point is the electric field is always perpendicular to the element dl of the equipotential surface. Electric field is always perpendicular to the element. Just imagine, since work done due to electric field is 0, what is the formula of work done due to electric field is 0? That is minus sign electric field into displacement. Okay. And work done is 0, it means E dot dl equals to 0. And E dl cos theta is also 0. If E is not equals to 0, it means there is electric field. dl is not equals to 0, it means you are moving the charge. Then what will be 0? Then cos theta will be 0. And cos theta will be 0, it means theta is equals to 90 degree. So we can say the electric field and the element dl both are perpendicular to each other. It means if you are taking dl on the equipotential surface, then electric field and dl both are perpendicular to each other. Now third point, equipotential surfaces indicate region of strong or weak electric fields. As we know that electric field is defined as the negative of potential gradient. It means E equals to minus dV upon dr or dr equals to dV upon E. And if dV is constant, then we can say dr is inversely proportional to E. If dV is constant, then dr is equipotential, is like inversely proportional to electric field. So we can say E is stronger, then dr will be smaller. And And what does it mean? Suppose there are so many equipotential surfaces like this, and these are the spacing between equipotential surfaces. So we can say here the spacing between equipotentials are less, so here the electric field will be stronger and here the electric field will be weaker. It means if equipotential surfaces are crowded, then electric field will be stronger. Next point, two equipotential surfaces cannot intersect. Why cannot intersect? Because if you are intersecting two equipotential surfaces, then at the point of intersection, we can draw perpendicular to the intersection and you will say that there must be two electric fields are there, and which is never possible. So, two equipotential surfaces never intersect each other. Now, these are the diagrams which represents the three-dimensional figure of equipotential surface of uniform electric field. You see here the electric fields are parallel to each other and perpendicular to the electric field there must be equipotential surface. So the shape of equipotential surfaces are plane. Now you see the three-dimensional picture of equipotential surfaces of a plus charge. You see here the electric field lines are radially outward from the charge, so potential surfaces are concentric spheres like this. And now you see the equipotential surface of plus charge, equipotential surface of dipole, and equipotential surfaces of two equal positive charges. If you are taking negative charge, then same diagram will be there, but arrows are radially inward. And if you are taking here two equal negative charges, then arrows will be inside the charge, but equipotential surfaces are same. Now, we are having some questions based on equipotential surface. First question is, what will be work done in taking a point charge from one point x to y on the circumference of given circle? And here is a charge plus q charge. So this circumference represents the equipotential surface, and as we know the property of equipotential surface that there will be no any work done in moving a charge on the surface. So work done will be 0. Why it is 0? Because it is equals to potential difference between the two points into test charge. And Vxy equals to 0, so work done will be 0. Next, what is the relation between electric field and potential gradient? Obviously, electric field is equal to minus sign of potential gradient. Next, what is the geometrical shape of equipotential surfaces due to single isolated charge? If single isolated charge, then geometrical shape will be spherical. Now, if I am asking you next question, is they are the equally spaced? The equipotential surfaces for this question, they are equally spaced? Your answer will be no. They will not be equally spaced because electric field is inversely proportional to R square. So, and potential is inversely proportional to R. So, they are not equally spaced. Now, this question is your home assignment. Do this question in your copy and show it to your teacher. Thank you, students.